Continuing on with 4.13 hydrolysis of salts, acid bases, Chem 12. I did the first 4 examples. This is my note sheet, and in part 1 I did 1 through 4. So skip down to here, and we will start part 2 of our video with example number 5 where we left off. Okay, example number 5. Na is my spectator, so I'm going to get rid of that, and I'm going to be left with HC2O4 minus. So this one is an amphiprotic ion because I have an H and I have a minus, so this guy is amphiprotic. Okay, when you do an amphiprotic ion, you're going to need to do 2 equations for each ion. So I start my amphiprotic by doing H2, oops, sorry, that shouldn't be H2. HC2O4 minus plus H2O. And I write the exact same thing underneath it, HC2O4 minus plus H2O. So I started with 2 identical equations. In the top equation, I'm going to donate my H. I always follow this pattern with donating first. So C2O4 2 minus is my ending, plus H3O plus. Okay, so the next step of this, we're going to be looking up a Ka value for this, and I'll come back to that once I've written my second question. And then this one, I'm going to go the opposite way with my H, and I'm going to accept an H. So this is H2 C2O4 plus OH minus, and this is a base, which means I'm going to need a Kb. Okay, so in this case, this was an acid, and in this case, acid donate, and in this case this was a base and I accepted. Develop your own pattern, but I always do my top equation with the donate and my bottom with an accept. So now that I have my 2 equations, I need to go to my table and find Ka and Kb. So Kb you can't look up directly on your table. You have to do the equation 1.00 times 10 to the minus 14 over Ka. So now we're going to go to our table and we're going to find the Ka for both of these. And I have highlighted this one in blue. So here, this is where my ion is acting like a base. It is on the base side of my table, so I'm going to do what I call flip this to a Kb. So flip to Kb. Okay, so this is actually my base side, so that's going to be my base number. It'll be 5.9 times 10 to the minus 2. So I'm just going to go back to my notes and write that in. It was 5.9 times 10 to the minus 2. And while I'm there, I'll take a minute to type that into my calculator. And I will find that my Kb is 1.7 times 10 to the minus 13. And I still need to find my Ka. I just happened to find Kb first when I went to the table, so I'm going to go back to my table. Again, highlighted in the turquoisey color. Right here, scroll down a little so you can see it. There is my ion when it's acting like an acid. Okay, this one is written direction as written, so this here, that's when it's an acid, that's a Ka value, and that's the exact number I use. I do not need to change that. So 6.4 times 10 to the minus 5 is what I'm going to write in up here. 6.4 times 10 to the minus 5. Okay, and now like many of our other equilibrium equations, we're going to compare these 2 numbers. So Ka, Kb, that guy there is bigger. So just like all of our other ones we've done this with, this is bigger. That means it's the winner. And I would answer that this solution is acidic. Okay, and I like to put a box around that to really highlight to my teacher that that's my answer. So a question that is amphiprotic is more likely to be out of 3 marks because you would get a mark for each question and you'd get a mark for your answer. So if you see questions that seem to have 3 marks, you're probably looking at a question that has to have 2 equations and you need to figure out a Ka and a Kb. And then you compare them as I've highlighted them and decide who is bigger. The bigger one is the winner. Okay, a similar situation in number 6, except it's not amphiprotic, it's just that neither are spectators. Okay, so if neither are spectators, again, you need 2 equations. So my first equation, I'll use my first ion, which is NH4 plus H2O. And in my second equation, I'll use the other ion, which is NO2 minus plus H2O. And I got my ions by splitting that guy like that. Okay, and that's my plus, that's my minus. Similar to our KSP unit where we split up salts. So my top equation, NH4 has to donate because it's NH4, it has that extra H plus, so NH3 plus H3O. Okay, this tells me I'm going to use a Ka, and I can look that up on my table straight up. And this has to accept, it has no choice, so if I accept my, this way, I'll write my base 1 in blue, this would be HNO2 plus OH minus, and that tells me, oh, I'm going to need a Kb. So before I go look those up, I like to remind myself I have to flip the number for my Kb, so I do negative 14 on the top, Ka on the bottom. So now I'm going to go back to my table, and I'm going to find the numbers, and I'm going to look for the NH4 first, just to get it out of the way. NH4 down here, this guy, ammonium ion, we use it all the time, so 5.6 times 10 to the minus 10 is the number that I'm writing on my page. Okay, and now I'm going to go look for my next one, which is NO2 on the base side of my table. Back to my table. Down my base side. This is my base side, so I'm looking down here. Careful, that's NO3. Don't fall into that trap. Keep looking. There's NO2. Okay, so the NO2, this was my starting, and if I read my equation, it's exactly reversed of what I wanted. Okay, so this means I'm going to flip. I want a Kb, so I need to flip it, which means put it under 1.0 times 10 to the minus 14. So I'll go back to my original note sheet. Oops. Was down here. There we go. And that number was 4.6 times 10 to the negative 4. When I do my calculation, will turn out to 2.2 times 10 to the minus 11. And then once again, I'm just going to compare my two numbers. So I have my Ka, I have my Kb, that's Kb. And once again, that one's bigger. So we have our winner, bigger. I always label the one that's bigger in case the teacher asks for an explanation. And again, my answer is this salt solution would be an acidic solution. And one last here to deal with the weird aluminum ion. In this example, here's my aluminum, here's hexaaqua. This is a spectator, NO3, which means really what I'm dealing with is Al, H2O5, 5 water, OH2 plus H2O. So before I write this, I'm just going to take you back to your table and show you why I have OH2 plus. Here's my aluminum example is down here. I'm going to need a new color. We'll use purple. This is the ion here that I'm starting with, and I'm going to be going backward. So Al2O6 is where I'm finishing. Okay, so this will make Al, so my H is going that way, Al H2O6 3 plus. Copied exactly off the table. And I donated an H to get there, so this is OH minus, and this solution is basic. Okay, so that's one that started with the negative ion, so this is my negative ion once I get rid of the NO3. Okay, so sorry, I shouldn't have called that the negative ion because it's the 2 plus. The 2 plus version, which is the one on the base side. And the 3 plus, I've put a little note over here about the 3 pluses. The 3 plus version are on the acid side. Okay, so in that case, your ion on the table, and they're all going to be acidic. And if you get one like example 7, where it's the 2 plus, they're all going to be basic. Okay, and now you have enough to start worksheet 4.13 on hydrolysis of salts.